Hi everyone, welcome to the video today, and a big shout out to those who regularly watch my channel now. Thank you very much, I do appreciate you. So wherever you're watching from, give me a big shout out, and to our regular viewers and subscribers, to Patrick in Ireland, Charlie in Canada, and anybody else who's watching, nice to see you again. Anyway, what have I been up to? Well, it's now, what's the time in the UK? It's almost 10 to 4 in the afternoon. And I started this project just after 11 this morning. So I've been spending quite a few hours today just basically wiring up. So over here I've put these terminal blocks in. And these are a 16 volt accessory side. Next to it here you've got the 12 volt track supply. And unfortunately I didn't have any model railway wire as such, which is this sort of thin grade stuff, which I've got in green and red there, as you can see. But I did have quite a lot of ex-home theatre wire, which used to be on my surround sound system. So I managed to nick all the wire off that before I threw it out, and it's great. It actually does work. It's not a very attractive colour, but it will do the job. It's not all the same colour. That's what I'm aiming to do, and that's what aiming purposely you should always try and do on your railway at home, is keep the wires colour coded as best you can, then you don't get too confused. It looks a little bit confusing, all this lot. It looks a little bit messy, but it's the best I can do with what I've got at the moment. So what does it do? Anyway, if I come out the shot slightly, you can see now all my building lights and yard lights are all connected up. And I've connected them in a series circuit. So basically it's one leg of the wire to its next door neighbour and its next door neighbour, and then the last wire goes with the first wire of the first lamp, and they go as a pair to the switch. And obviously I've put heat shrink around the solder joints to stop them from getting pulled apart or damaged, and it obviously keeps them nice and safe. So those are all in now, as you can see. They're in. I know it looks a little bit flapping everywhere, but don't forget, whether this is resting on a table or on legs, this is underneath the baseboard, and the idea is you put them through these holes that are when you buy the baseboard kit. So your wires, wherever they go, they can go through the holes without flapping downwards underneath the layout and getting caught on anything or anybody. My cat was a prime suspect for doing that all the time, going underneath my baseboard on the old layout and catching the wires. So this is basically a better solution, and I've tried to keep them as best as I can tidy wise. And like I said, I've used different wire because I didn't have any of the model railway grade stuff at the moment, so I used what I had. Quick question you might ask yourself, or I might ask me, can you use standard mains flex, what you use around your household for your kettle, microwave, toaster? And the answer to that question is no. I wouldn't recommend it. It's too heavy. It's too heavy for the amount of limited current going through the wire. That's more of a heavy current, like the mains voltage you've got where you live. I think in Canada, correct me if I'm wrong, it's 210. Over in the UK, it's 240 volts, which is the mains voltage. So this stuff is ideal anywhere between 12 to 16 volts DC and AC. This particular wire I've used here is off my old surround sound system, old speaker wire basically, and it does the job as long as it's pretty sturdy. I like using this coat, this red and black speaker wire, because it's nice and tough, very sturdy, and it obviously you can bend it and it won't snap, and I just like using it. I think it's decent wire for what you want. So where does it all go? So as mentioned, yeah, it's all connected up and it goes into these terminal blocks, and you've got an input side on one side. So you put on one side your terminal blocks, you put whatever accessories going into it, whether it's a light, point motor, or whatever you've got, and then the output side, this goes to your switch or directly to your controller. And then obviously to make life a lot easier for a plug and play system, which I've designed, I've put all the wires together in one big long flexible chunky cable affair like this. Just put some more heat shrink around it to keep it together a little bit, and at the end of it, it goes into another terminal block like that, and I know exactly what I'm plugging into. So this is basically a 16 volt supply. So again, input side where my thumb is along one side, and then the empty side, these will go directly to the switches on the separate control panel shelf that I've made and that you saw in the last video. And this little separate little guy on the end with the red tag or the red heat shrink that I've put around that as a separate wire, that end wire, I know exactly what that does, because if we come up to here, those wires correspond there to this end set of wires on the little plug thing here. So that I know is a separate thing. It's not lighting. These are all lights on this side. This separate little guy here is for something else, and I'm going to show you what that separate little guy does. Let's put that down there. Now then, do not adjust your television sets at home, because the layout is skew width on its end. And I'm going to show you something here. Oops. Come on, behave yourself. That's it, I can let go now. See, it stands up under its own weight. This here, I'll bring the camera in, if it will let me. Come on, please. There we are. Right, now, a couple of you out there, a couple of you have been asking about doing an update or information about how to do an isolated section of track on your model railway. So what is an isolation section, or what is an isolated section of track? Well, as the name suggests, it is basically a section of railway track on your layout that you can electrically isolate. So you can store a locomotive, one or more locomotives on a section. So for example, let's just say in my scenario here, I've got the ash pit and coal in stage facility here. Well, I've got ash pits obviously there, but what I was trying to say is the scenario is a locomotive comes onto this particular road here and stops the coal up. And then there's another locomotive behind him that wants to come up and also refill. So if I flick a switch where these two wires are now soldered, come on camera, basically you can, at the flick of a switch, you can energize this section or you can de-energize it. It's a simple on-off system. And as mentioned in my old video, it's not much different from the old one I did. Basically, I used a rotary tool just to cut through one side of the fish plates there that are holding that section of rail together. I just cut through one side of the fish plates on one completely through to the baseboard. So there's now a physical gap between those two sections of rail. And then you just solder a cable each side, piece of wire each side, drill a hole, stick it underneath the baseboard, and then run the wires, as mentioned, to your connection to go to your switch. And that's pretty much how simple that is. The principle, as I explained in my old video, which I did many years ago, which has got quite a few comments and views, the principle is still the same. Nothing's changed, and it is that simple to do. You can use a rotary tool for speed and precision, or you can use a razor saw, a track saw. I tend to use a rotary tool because it's faster and it's much more easier. But yeah, guys, just cut yourself a little slot through the rail. It doesn't have to be on a fish plate, by the way, or a rail joiner. It can be anywhere you want on your piece of track, as long as you make a physical gap between one piece of rail to the next, and then you put a cable either side of the brake, and those two wires, they run up to a switch. You don't need to use any power as well. So let me just zoom out. I'll just swing this back the other way. Like that. And that leans up there like that under its own steam. So as mentioned, where are we? Up here. That's what I just showed you just a few seconds ago. That's where it comes up underneath the baseboard, or underneath should I say, and then it basically runs along there, down through that clip, through that hole, and then it goes to the terminal block onto the input side, and then the output side is another separate pair of wires you just connect up, and that goes to your switch. So the switch in question will basically have another set of wires going from the switch to that end terminal block with the red coloured heat shrink on there where my pinky finger is poking. So it's that simple. And I think it was Charlie in Canada asked me a while ago, do you need to use any separate voltage or anything from your transformer to wire up with the switch to make the isolation section work? And the answer is no. It's the beauty of that system. You don't need to connect up any external power source in terms of train control. You just basically use an on-off switch. As long as you make sure you've got an on-off switch. Obviously you don't want an on-on switch because it defeats the object, it won't work. But what you need is a simple on-off switch. It can be any on-off switch you can get your hands on. I always find a little tip that you saw me use in a really old video that I'm talking about in question. I happened to strip down, I think it was something, a child's, one of those, you know, flashing little toys that you put the little LED, the coin batteries in. You get them at Christmas and they sort of glow and change colour. My daughter's one had broken, so before I threw it out, I nicked all the bits off it, because that's what I'm like. I strip things down, what can I use? And a simple little cheapy on-off switch. As long as it's half decent, you can use that, for example. Can you use a light switch? Absolutely. If you want a big chunky switch to put it up to, you can do. Use what you like. As long as it's a decent on-off switch. That's the theory behind it, because inside the switch, there's a copper contact on a spring rocker. And what happens is when you press or flick it, it engages that copper plate between the two wires that are connected up to it from your track section, and that basically energizes your track through that. It creates a bridge. So basically the two wires take the place of a fish plate, and you're creating that obviously with the switch, and that's all you're doing. And the beauty of it is you can switch it to one side to energize it, or you can de-energize it. And the great thing about it is it's fun, because there's so much scope for stuff like that on the layout, because it's great, for example, for shunting. For example, let's just say you bring a loco in with a freight train, for example, or passenger train. It's got an engine on the front. You stop it, and where the section of the loco is you've stopped it at, there's an uncoupling system. You uncouple the loco, and then you run it forward, and you flick your switch. That loco's dead. You bring a loco in on the same road to pick up the coaches or wagons, and away it goes. And there's loads of possibilities with that. It's a fun little idea, very simple idea to do on the layout, and it's easy to do. So that's where I'm at with today's little bit of work on the layout. I had to reinstall the light inside the signal box because it came adrift, and obviously the solder joint was a little bit old, so I just cut all the wires and started again and tidied it all up, and that is it. So in theory, what is going to do what, as mentioned? Well, in terms of how many lights work off one circuit, well, basically, let me show you how it works. So, for example, you've got this yard light, which is next to the signal box. That's one light. Underneath here, this pair of wires goes into the signal box for the signal box light. That's two lights. And then if we come down here, there's a yard light behind the signal box. That's the third light. So that's three lights on one pair of wires, which is the black tag wire on there. The blue one, sorry, start again. The yellow tag on this set of wires, that powers up that yard light, and that yard light, and that yard light. That's three lights. And then the last tag on here, where is it now? Come on. The blue one, that will power up that single yard light and these black cables that run to the LED light underneath the canopy of the goods depot. Obviously I didn't want to add any more than 2 on there to get the maximum effect of the LEDs, which will work nicely with the other light. It will glow slightly brighter, but not that much. But the idea and principle is with lighting on your model railway, excuse me, just sit down a bit better, that's it. So I'm squished on the end of my bed here in between the baseboard. One of the ideal principles of model railway lighting, to explain it really simply, is if you think of Christmas tree lights, they're all wired in series. So you get the same brightness throughout the circuit. And if you remove one bulb, in theory, the rest will go out, or you'll have a non-working circuit. With Christmas tree bulbs, it's a little bit different because the way they're made these days with the LEDs, they're pretty reliable. But the old-fashioned screw-in type that I grew up with in the 70s, you always had to replace a bulb if one went out. It was normally the offending bulb that blew it, and you just went to Woolworths and got a spare bulb and screwed it back in. Wow, there's a name, Woolworths. That's an interesting question, actually, because for Charlie in Canada, who's watching this probably, I'm not sure, but I think in like Ontario or parts of Canada, you had Woolworths in the 1950s and the 60s and 70s. I'm not sure if you still got them over there. That's interesting, though. But yeah, the principle, and I'm digressing, sorry guys, but the principle is basically a series circuit. And why do we use a series circuit when it comes to wiring up your model railway lights? Well, it's quite simple. If you individually or separately connect up a light with a pair of wires to a switch and directly to your 16 volt or 12 volt supply, it will do its maximum potential brightness. It'll really be bright, but it won't last very long. It will burn out. Whereas if you underrun them, what's called underrunning your railway lighting is basically you wire all your bulbs up in groups of about 3 to 4. You can do 5. On my old layout, Bentley Park, I had often 5 yard lamps connected in series together as a group, which is basically what I've done here. Just grouping your lights, basically, guys. Group them in groups of 2, 3s and 4s. 2's okay, 3's better really. Even though I've got 2 separate lights here, it will still work. But ideally, 3 onwards, 3 to 4. 3's a nice number actually. You'll get a really nice warm glow off your lighting, and it will last ages. They'll last pretty much forever. The only reason I had a few of these lights go is when I obviously moved house and I dismantled the layout and I unboxed everything, and obviously I tested all my lights and I found a few had not become damaged and weren't working. So the remaining couple that I had, hence I've put it back on the layout and tested them, and they should all work lovely. Anyway, a long waffle from me today, but if that's helpful to you out there, that's the main point of the video today. Because as always, my videos are not always aimed at the advanced modeler or the modeler who's come back into the hobby after a long time, but it's also the younger people out there, the younger generation that are just starting to get into the model railway side of things. And YouTube can be a wonderful, wonderful tool for tutorials and how-to videos. So if you found this video by accident or purposely googled up how to install model railway light wiring, or the best way to wire up model railway lights, I hope some of the things I've showed you so far has been a little bit helpful. Anyway, I think that's about it from me today. If there's any questions you guys have further, please drop in the comments box below, and I will definitely try and answer them to the best of my ability. Like I said, if you try and group your lights in little groups of 3s, even 4s, you'll find that that's much easier and they will last a long, long time. What you don't want to do is never ever connect up a 12 volt bulb or a 16 volt model railway bulb directly with the full voltage going through it, because it just will blow it. LEDs don't like 16 volts full voltage, they just don't like it. So always try and underrun your lighting. LEDs are a little bit different. Before I go, LEDs are a little bit different, guys. They're a different bag of tricks, because you've got to solder and connect each leg of the LED terminals correctly. There's a short leg and there's a long leg. And you can use resistors. That's a whole new electronics story for another day. If you want to know how to do that, one of the videos or channels that I can recommend before I go is John Chambers. Guy lives in Nottingham in the UK. His channel is Champs123 or John's Amazing Trains, I think. Do you know what? Anybody out there know what's happened to the guy? Because it's been ages since he's posted videos, and I've looked on his channel, and it's been a long time since he's posted anything. I know I think he lost his mum a while ago, but I'm not too sure how the guy's doing. But if anybody out there regularly talks to him or is in communication with him or knows what's happened, let us know, because let's all help each other out in this community. Because if we know someone's not with us, or someone's just shut down their channel or something like that, and we might know this information because they're a good guy, let us know so we can know this information. But he's been really helpful to me. I know I haven't said to him directly, but I'm sure, like most people out there, from watching John's videos, they are very, very good, because the guy is an electronic wizard. He started his own business when he left school, I think designing and repairing amplifiers and things like that. Very clever guy. Anyway, that's where you should go to, and channels like that, to find information on how to solder up LEDs. But for the basic purpose of 12 volt DC model railway lights, this is roughly how you do it. And also, if you're interested in making those isolation sections, again, that is how you do that as well. I wasn't going to show you me cutting through the track with the rotary tool and soldering up, because most people know how to do that. But there we are. Anyway, I am going to go and leave you now. So have a lovely day, rest of the weekend. It's a beautiful day out here in the UK. Wherever you're watching from, have a lovely weekend. Thanks for joining me. And don't forget to hit the like and subscribe button, guys. And I'll see you soon in the next update. Ta-da now.